Hi, so I gave a test to the grade 12 learners on vectors and transformation. So I'm going to go directly to the questions of the test. If you want a copy of this test, you can also get it on the Google Classroom. Right, so they are saying these vectors A, B, and C are such that vector A is negative 9, 4, vector B is 2, negative 2, and vector C is negative 8, negative 2. So you were supposed to find the modulus of A, that means the line segment, and we use Pythagoras here to find the modulus of that vector. So I was expecting an answer of 9.85 if you round it to 3 significant figure. Right, then you're supposed to find as a single column vector, so 5 times vector B minus vector C, all right? And then obviously you multiply that 5 with each of the components in the vector, and also the negative 1 here with each of the components in that vector. And that should give you 18, negative 8. This one was quite straightforward, and the students got this one right. Then they are saying explain why vector B, 5b minus c is parallel to vector A. So if I bring them up, you should see, well, so I compared them. So there's some scalar quantity here, right? And if I calculate my k, I know that, okay, so the scalar quantity is negative 2. So these vectors are actually parallel because they are scalar multiple of each other, all right? So that is what you're going to get. If you multiply this vector by negative 2, you're going to end up getting the same as vector 5b minus c. The B part is a diagram here. So the diagram, they say the origin here is O, and Q to R versus R to P is in the ratio 2:1. They are supposed to find the position vector. So if I find Q to R is 2 over 3 parts of that ratio, and then obviously this is 1/3 of that particular distance. Right, so when they are saying position vector in terms of R, that means you are required to start here at O. So it's effectively that particular vector there. Okay, so there are two ways you can do this. Effectively, you see, it's a way that you can go from O to R. You either go O to R equals to OQ plus QR, or O to R equals to OP plus PR. So it's totally up to you how you want to calculate. And something else that you realize, you are supposed to also know what is vector QP in terms of Q and P. All right, so I then took the decision, or the first part, to do OP plus PR. Okay, so I know that OP is P, vector P, and then O or P to R is 1/3 of the line PQ. So on the side here, I then find what is the line P to Q. Go from P to Q, it's the same as going here against this vector P, wait for the minus is here, all right? And then obviously plus Q, all right? So it's minus P plus Q. Then I take that and then I put it in here for PQ. And so the only thing is I need to clean up the algebra here. All right, so 1/3 times negative P is negative 1/3P, and 1/3 times Q gives you 1/3Q. So when you collect the like terms, it's like 1 minus 1/3, or 3/3 minus 1/3. So it gives you 2/3 P plus 1/3Q. Ultimately, if you were deciding to take the alternative method of going from O to R by going O to Q, plus 2/3 of the line QP, right? So on the side, if I find again the line Q to P is I'm going against this Q here plus this P here, and I just punch that in here in order for me to sort of multiply that 2/3 over. And when you do that, you will also realize you get to the same answer as what we had before. So you have got 2/3 times negative Q gives you negative 2/3Q, and 2/3 times positive 1P gives you that. When you subtract 3/3 minus 2/3, or 1 minus 2/3, you get 1/3 plus 2/3P. So that is the way you could have done these questions. Either way, you will still arrive at the same answer. Then they're saying use vectors to find the remaining vertex of, so I'm giving you here a parallelogram. And what you can see here is that the shapes are not, the sides are all equal, and also they are parallel. Okay, and what you have also to realize is we're supposed to find the coordinates here. All right, use vectors to find that vertex there. So, well, So, and also you see it is labeled in a clockwise direction, okay, A, B, C, D. And from our diagram here, you can see that BC is equal to AD, and not only are they equal, they are also parallel. All right, so when I find BC in terms of position vectors, BC will be OC minus OB. Please have a look at one of the videos that I have done on vectors, how to find, I hope you can remember, if you are supposed to find vector AB, all right, using position vectors, it is going to be the second point, OB, all right, minus the first point, OA. All right, please don't forget that. So if you have EF using position vectors, how do you find E to F? It is the second point, OF, okay, minus the first point, OE. All right, so that is just going to be, that is what I've done here for BC, and I've done here for AD. All right, so please have a look to you to be able to go back and see if you can recall how to write vectors as position vectors, okay, because you have got vertices here, and vertices can be written as position vectors. All right, and that is the way we do it. All right, so I have O to C, or OC is that coordinates, and writing it as a column vector is 2, -3, -3, -2, and here I've got X and Y here. So know that the two have to be equal. I can simplify 2 minus 3 gives you -1. -3 minus -2 is the same as -3 plus 2 gives you -1 here. All right, when you do the same here, -3 minus X, well, that's just what it's going to stay, and -5 minus X is -5 minus Y is -5 minus Y. So now I'm taking a row, so I'm going to take the top part, okay, to find the X component. What is that X value? And I solve the equation, adding 3, all right, then I divide by -2, so the X will be -2. Then I do the same for the Y, take the Y row there, okay, so -1 equals -5 minus Y, and you add 5 on both sides, and you divide throughout by -4. So that missing vertex is supposed to be -2, comma, -4. Right. Question 3 says, in this particular figure, O is the origin. It's very important when you're told something is the origin, because they're going to do something similar like what I did in the previous question. They're probably going to ask you or tell you that O to X is a position vector. All right, and then you have to use our knowledge of position vectors. All right, so we also see that OV is V, and represented by V, vector V, or U is represented by U. In fact, VW will also be vector U, so will be UW here will be vector V, because it's opposite sides of a parallelogram are not just equal, but they're also parallel. Okay, then we also know that this particular line here, so the ratio 1:4, so this from W to X represents 1/5, and from X to U represents 4/5. So they want us to find UX. So that one is straightforward. We know that the whole U to W is U, or V. So U to X will just be 4/5 of that V. Then here we go again, the position vector of X. So I'll bring in my line starting from the origin. So that is what they want us to find. So again, it's up to you. How do you go from O to X? It's either you go OU plus UX. We already know what UX is, and we know what OU is. For me, that will be the easier and straightforward sort of route to take. Right, bringing the diagram back, they're saying that OX is extended all the way up to there where Y is. All right, and they tell us that O to Y is the same as 5/4 of OX. Okay, so we know that O to Y, because we're told here, is 5/4. We know from our previous what OX is, so I just punch in my OX in here. Okay, and then I clean this up. I'm getting that OY is equal to 5/4 U plus V. All right, so that gives me O to Y. But we are looking for V to Y. And to go from V to Y, okay, V to Y, that's the same as going, and here is very important, V to y. If you had to draw a line all the way, all right, if you had to draw a line all the way from, and this is kind of very important, so we just bring that line in there, a line all the way from V to where my W is, then in order for me to find that particular vector, I'll travel the same to find Vy. So I'm going to find Vy. So I can go down here, okay, which is against this, and then I go along this one here, which I already know what that one is, okay. So that is going to be minus V plus that stuff that I already worked out. And so the only thing that is left for me is just to simplify all of that. And when I simplify, I end up with 5/4 of U. So now I know that VW is U, and this V to W is 5/4 of U, which means these two must be parallel and also perhaps collinear. So what can you deduce, right? So we have got VW is equal to U. So what that means is we can use our knowledge of what we know from our diagram, okay? We know that this here is vector U, all right? And we know that this little part here all the way represent this 5/4 of U. All right, so that means that V to W is equal to 5/4 of V to W. So that whole thing is an extension. It looks like it has to be parallel, okay, by that number of times. And also you can see that it means that V, W, and Y therefore have to be on the same line, okay, and by that ratio there. Question 4, well, it's about transformation. So I bring in my diagram. They say describe fully the transformation that shapes A onto B. Well, you can see it is a reflection, okay, and the line of reflection is the y-axis, or you can say the line x equals to 0. Okay, that's how you can describe it. 2 marks. You need to tell us its reflection, and then you need to tell us the line of reflection, which in this case is the line x equals to 0, which is also known as the y-axis. So you could also write the y-axis, but here's the thing: don't always think that all reflections are going to be just the y-axis or just the x-axis. You need to give the line, whether it's a horizontal line or a vertical line, okay. Then you are supposed to describe fully the transformation that maps B onto C. Well, you can see it's an enlargement. It's quite straightforward. The next thing is to find the center of enlargement. So you can draw a line where you join the corresponding points, and then you realize they meet somewhere here. And that is the point -4, -2, -2. So that is also then the center of enlargement. So the only thing that you need to then figure out is to find the scale factor. Now the scale factor, and I am using a different measurement here. You can now, when you want to find the scale factor, all right, what you can do, you can also look at the center of enlargement, and you can take a point. Suppose I take this particular point, and I want to know how far is, let me call that point A, all right, and I call the corresponding point here A prime. So I want to find out how far that point is, all right, as a vector from the center of enlargement. So where the point A, all right, A from my center, all right, so I can call my center, maybe I can call my center, let me call my center what, I don't know, a T or a C, all right. So from C to A, I'm going to get 2 units, or 1 unit rather, all right? It's going to be 1 unit across and 1 unit upwards, okay? Obviously, you must make sure that your scale is working out. So I'm going 1 across in this direction, and I'm going 1 up in that direction. If I then look from my C to my C prime, that distance there, all right? So that's going to tell me I'm going 1 here, 2. So I'm going 2 up Can you see that? And I'm also going another 2 to that place. So by the looks of it, that my scale factor has to be twice that much, okay? My scale factor is twice that much because it's twice so far. All right, then this is how you find. Ultimately, the best thing to do, you don't really also need to work with vectors. I can use this vertical distance here, all right? And this vertical distance here is 1, 2, 3, 4 units, all right? And I use the corresponding distance of the smaller one that is all the way here, and that is 2. And then obviously 4 divided by 2 also gives me the 2. All right, and that is how I find the scale factor. Right, so let me bring the diagram back. So what they are requesting us here, they are saying we are supposed to draw, okay? We're supposed to draw and label D. So what we're drawing is a rotation, okay? Shape A is rotated, and the center of rotation is this one here. So when you rotate it, and that is what I expect it to be, 90 degrees anti-clockwise. Then the second one we're supposed to translate. Translation is just you have to slide B, all right, by that vector. So because you have negative, so you're going to take it 3 places to the left, and you have a positive 2 here, then you go 2 places upwards. So it's going to, its new position will be there. When you translate a figure, its shape doesn't change, all right, it just slides to the left, to the right, right. So up or down. Okay, question 5, you are supposed to do repeated transformation. So this is nothing complicated. You have to take triangle 1 and then you translate it twice. So I'm going to translate it by negative 2 comma negative 2 1. That means 2 places, take any point, move 2 places, go 1 up, and that's not all. You have to do it again. So when you do it again from where we are, the black one is where it ends up after it undergoes that repeated translation, and that is where the answer should be, and that is the particular answer that we were looking for. Right, so the very last question in the series that I have here is I have got something similar as the core, but you're supposed to label and the center of rotation, label it with that little X there. So what you do is obviously you'll take your tracing paper, you trace this and then you find points here, any point that you can see. Maybe you start with 2 comma negative 1, maybe you start with 1 comma negative 1, and so on until you find a point. As you are rotating it, then you see where will this triangle be superimposed. It will fit exactly on top of this. What point would that be? And when you can realize that point, then that point is your center of rotation, okay? And it is the point 1 comma negative 2.